And this time we will be talking about fossils. So what are fossils? So these are actually preserved remains or the trace of the ancient organisms that live long way back for maybe a couple of thousands to millions of years. Fossils are actually not the remains of the organism itself, but they are maybe sometimes an expression of themselves in the form of rocks and minerals. So fossils can preserve an entire organism or maybe a part of that organism, such as bones, shells, or maybe feathers and leaves. And we will be discussing the rest of the details about this in the coming slides. Fossils. Fossils are the remains of plants and animals that live a very long time. And fossils are studied by what we call paleontologists. So paleontologist is actually a type of scientist that studies about the history of the life on this planet through the fossil records. And of course, fossils are also dated using the radio dating. So what is radio dating? Radio dating is actually radioactive, short for radioactive dating. Another name for this is radioisotope dating. And this is based on the comparison between the observed of the abundance of the naturally occurring radioactive isotope in our surroundings and compared to that to the decaying of the isotope that was deposited on the fossil. So this is known as the decay rate, and that decay rate will actually tell the time. And this radio dating will help reveal the Earth's history as if it's like a piece of a puzzle that is already completed, and it will reveal the history of the Earth. And it is known that the Earth was formed at about 4.54 billion years ago. And there are several types of fossils. These are the body fossils, and the other one is trace fossil. So what are trace fossils? Well, we have the first one, which is a track or tracks fossils. A track or a trace of footstep of these ancient organisms that once walked on our Earth's surface. And next is we have trail fossils. These are actually made by the ancient worms and maybe worm-like animals. They left trails in the ancient deposit and are already fossilized. And then another one is the egg fossils. So eggs can also be fossilized. These are the remains of the eggs that were laid down by the ancient animals, including dinosaurs. Another one is burrows fossil. When we speak of burrows, these are holes or tunnels that are excavated into the ground or even in the seafloor by the animals to create a space that is suitable for their habitation and maybe also a temporary refuge or as a byproduct of the locomotion that are preserved in the rocks. Another one is the like drill holes, or we call it the boring or borings fossil. So borings or boring a hole or holes where an animal or ancient animals dug into a hard substrate like wood or rock and eventually are petrified and are preserved as fossils. To continue with the trace fossils, we have the knowing fossils. When we speak of knowings, mammals or ancient mammals have been gnawing on bones for calcium and protein to supplement their diet for millions of years. Another type of fossil is a dung fossil. Another name for this is coprolite. So coprolites are actually fossilized feces or dung of ancient animals that also live for millions of years. Another one is the nest fossil. So dinosaurs, for example, build different types of nests for their eggs. So maybe around tens or millions of years ago, dinosaurs built nests to keep their eggs warm because dinosaurs are cold-blooded reptiles. And the bizarre type of fossil that you see here is called gizzard stone fossil. So gizzards or gizzard stones are also known as gastroliths. These are fossilized gizzard stones. These stones are taken by the ancient organisms to help them grind food into pieces, as like the work of how a stomach muscle do. So when we speak of trace fossils, as a recap, trace fossil is also known as ichnofossils or trace fossils. These are the geological records of the activities and behavior of the ancient animals. And going back to trace fossils, there are several types. One is tracks fossils, trails fossils, burrows. Another one are eggs or eggs fossils, gizzard stones or gastroliths. We also have borings, knowings, and nest fossils. At the same time, dung fossils or coprolites. Moving on to body fossils, these are the most common type of fossils, and they are from the remains of dead animals and plants. Unlike the trace fossils, you cannot find an impression of how an animal looks like, but in a body fossils, here we will be able to trace the type of shape, morphology of a ancient animal through the body fossils. A type of body fossil is called an altered fossil. Altered fossils has changed and the material is different from the organism when it was still alive. So here is one example of an altered fossil, and this is a three-dimensional fossil that is an impression of the remains of the organism that was buried in sediments. So this type of fossil is called mold and cast. You can see that the mold is in one side and the other one is called the cast. So here is another example of an altered fossil. The original organism material dissolves and is replaced by the groundwater minerals that creates this type of fossil called the replacement fossil. In this example, this is a calcite, and the calcite is the replacement of the original material of the, for example, this type of fossil. So during the process of replacement, the pores, for example, of the original material enlarge, and then eventually it will form also new pores, and the disappearance of the displaced mineral will somehow be filled with the new mineral, and in this case the calcite. So this is how the replacement fossil works. So another example of altered fossil is a condition when an organism is rapidly buried in a low oxygen condition, and it can create a carbonized fossil. So it is usually a thin film that are found on rocks, and it creates the impression of the original organism. So another type of altered fossil is the original component of the fossil material recrystallizes to form the recrystallization fossil. And in this example, fossil shells made of aragonite will recrystallize into a more stable form of the same compound called calcite. So there is no replacement. However, the original material only dissolves and recrystallizes back, and it creates the same impression of the original organism. Another type of altered fossil is called permineralization fossil. So the pores of the dead organisms are mineralized from the environment, such as ground, lakes, and ocean. So for example, this is what we call a petrified wood. This is actually a type of fossil, a special type of fossil remains of terrestrial vegetation, like a tree or a wood. So petrification is actually the result of producing a tree or tree-like plant having been replaced by stone via a mineralization process. This is often included in what we call permineralization process, and it's very similar to replacement. So after giving you some examples of altered fossils, now we will be moving on to unaltered fossils. These are the remains of the original material when the organism was still alive. So if you have seen the movie, the Jurassic Park, the original part, this is one of the scenes that was shown in that movie, and this material is called an amber fossil. So these are organisms that were encased in an inert environment, such as this type of fossil called the amber. And so what is really an amber? So amber is actually a type of fossil, or it is a fossilized resin of a coniferous tree during the early tertiary period, that is about 70 million years ago or even longer. Then the resin hardens and becomes less vulnerable to destruction by the outside environment condition, and they harden and they have the higher chance of being fossilized since it can resist the environment better than those other types of fossils. So again, this is an amber fossil. So this is another type of unaltered fossil. This is called the asphalt or tar fossil, that an organism is also encased in an inert environment, such as the asphalt or tar fossils, similar to an amber. So for example, an organism such as the beetle fossil that was actually dropped into a tar pit. So this is actually a water scavenger tar pit beetle that is very famous and can be found in the tar pit area in the La Brea tar pits in California. So they are actually shown in there, and together with other well-preserved mammals. So another type of unaltered fossil is the freezing mummification fossil. When an organism dies, the freezing will slow down the decomposition of the organism, thus the whole body of the organism can be found. So we have two examples here. We have the Iceman. This Iceman was found in September of 1991 in the border between Italy and Austria, and this Iceman is said to live between 3400 and 3100 BCE. So another one is the best preserved woolly mammoth. The mammoth is named Yucca, and this is said to have died for about 39,000 years ago, and it was discovered by the local hunters in Siberia. So they eventually turned it over to the local scientists, and now the mammoth is displayed in the Natural Historical Museum in Moscow. So moving on to the conceptual summary of body fossils, the types are altered. For altered, the classifications are fossils with no original materials. The other one is fossils having the original materials but changed, and some original materials undergoing permineralization. For the no original material, the types are molds and cast, and replacement or pyritization or silification. An example to this is the petrified fossil. For the original material that is changed, the types are carbonization or carbon film. The other one is called recrystallization. For the other type of body fossil is called the unaltered body fossil, and the types are encasement. The other one is called freezing and mummification. For encasement, there are two types. One is amber. These are fossil tree raisins encasing the original organisms inside. The other one is asphalt and tar. Radiometric dating, also called radioactive dating, will help us tell the age of rocks or maybe the age of fossil samples. So in this example, we are going to have a sample of rock, and then we see that there are several atoms of uranium. And for example, if we found out that the half of the uranium atoms, in this case there are 12, so half of it is 6, so we have 1, 2, 3, 4, 5, 6. So if the molecules or atoms of uranium are already decayed into lead, so this is called a half-life of the radioisotope of uranium, and this half-life also has an equivalent time, so equivalent timeline. That is why it is so important for radiometric dating to be used, because the beauty of radioactive dating is that the half-life of a particular radioisotope such as uranium is unaffected by temperature. It's also unaffected by pressure and other environmental conditions. So in this case, we will be able to tell the time of that specific rock by calculating the ratio and proportion of the uranium that is present versus the decay, which is the lead. So for example, if we happen to see that there are only 25% of the uranium left, then the time is also calculated. So we will be showing you the formula in the next slide on how time is actually calculated by the radioactive decay. So this is actually the formula in getting the age of rock or fossil. So it is given by T is equal to 1 over lambda, and lambda is actually the appropriate decay constant. For example, we are using carbon-14. There is an equivalent decay constant for carbon-14 or uranium. So there is also a given appropriate decay constant for uranium. Multiply that with Ln times 1 plus D. D here is actually the daughter product or the decayed elements such as lead from uranium, and P here is the number of the atoms left or the parent atom of the isotope. So in this manner, it's easy for the scientists to tell the age of the specimen or the rock.